Okay, we're going to try to write the equation of a straight line for a set of data by hand. So I just gave you a table. You plotted all the data. That's what you have here, and it shows how much the tower piece leans with the lean in 1/10 of a millimeter. So here are your leans, and this is the year that it was measured in. So you can clearly see that you have a straight line type of a trend here, a pattern. So after you sort of plot it and look at it and decide that you can put a straight line on it, then the next task is, well, let's put a straight line on it, one that works well. So for example, if I did this line, I wouldn't think that does really well, because points here are pretty close to the line. Okay, a couple above, maybe a couple below, but over here on the ends, this one has a lot of error over here, and on this side I have even more error. So that's probably not a good line. So I'm looking for a line that has a couple of points maybe above, a couple of points below, and that does a reasonable job of estimating it. And it's not always easy to draw this. So you don't like this because I have all these dots over here that are really below. So I'm going to do this one more time, and let's say that I ended up with this line. Like that. Okay? Okay, so the next step is then pick some points that you think are really close to the line or right on the line that you can use. Now it's a straight line, so you only need 2 points. So I'm going to use this point over here, and I'm going to use this point over here. So I'm going to use those 2 points. Now remember I said you just made this table. So you would actually be able to read off those points a little bit more accurately than just from looking at the graph. So I'm using 78, for example. And then in my table, I can see that it's 667. And if I use this point, which is 84, then at 84, my table says that I'm actually at 717. So I know I can't read the 667 and 717 from the chart, but the table that I used to make the chart, it certainly is there. Okay. So then you go and you do y equals mx plus b. That's the format that we want. So we need to find the slope and we need to find the intercept. So m would be the slope, and b is our y-intercept. Okay, and we need to calculate those. So for slope, you can do change in y, so our change in our y divided by our change in x. So the change in y would be 717 minus 717 minus 667. It's actually a pretty even number, right? That's 50. And then 84 minus 78 over here. So the top is 50, and in the bottom I get 84 minus 78 is 6, and then I need to do 50 divided by 6, because in this case you don't really want to leave it as a fraction. So this is a word problem, so this 8.3 repeating, so I'll use 2 decimals on this one. So here's my slope. Okay. Once you have the slope, you can plug it into your equation. And let's see which parts we still need. Okay, now I can find my intercept. So pick either one of the points. And I'm just going to pick the top point and plug that in. What I mean with that is this. The 667, that is your y value. So this is a y value. So I'm going to put that over here. And this is an x value. I'm going to put that over here. And then I just go ahead and fill this thing in. So 667 is 8.33 times 78 plus b. Get a calculator, multiply that out. So 667 is, so this multiplied out to 650 plus b. Subtract 650, so that leaves you with 17. That leaves you with 17 for b. So your equation is going to be y equals 8.33x plus, so that subtraction gave me 17. And then again you should reiterate what x and y are. So x is the year and y is the lean. And then that would be it. Now, also keep in mind that you and I could have different lines and they could both be correct. Thank you.